Right. So welcome students to one more session of your 7-day inorganic series. So basically I've taken a long break. I think I was expecting most of the students to watch all the reactions of the previous video. In my previous video, what did I do? I have started with reactions of different inorganic compounds with water, right? Means basically we have done the addition of water to all these compounds. I've seen different products. Before that also I have sent you a video which has reactions involving action of heat. Now today the next important topic which I picked up is reactions with nitric acid. Okay, let me put the paper properly now. Yes, so here in this particular video I'm going to teach you how actually or what are the different reactions of nitric acid. It's a quite common question both in CBSE as well as for your NEET examination as well as JEE. Reactions of nitric acid being a strong oxidizing agent. So the very important. Let's start off. So when I speak about nitric acid, what is the other name given to this? Nitric acid is also called as aqua fortis, isn't it? Aqua fortis. What is the other name given to nitric acid? It is also called as spirit of, let us write that, it is called spirit of nitre, isn't it? NITER, right? So spirit of nitre or aqua fortis is nothing but nitric acid, right? So basically nitric acid, when I have to speak about its reactions and the different varieties of reactions with nitric acid is going to show. Let's see the combinations of nitric acid, both dilute, very dilute as well as concentrated. So the three different sets of reactions I'll be teaching you on. So first important thing you have to remember in terms of nitric acid is, let us list out the properties first. It's a very strong acid, right? So, and what is its speciality? Because it's a strong acid, it reacts with what? It can react with a wide range of oxides, carbonates and bicarbonates. Let's see, it reacts with basic oxides, okay? It also reacts with carbonates. It also reacts with bicarbonates. It reacts with, if I have to say, metals, right? It also reacts with non-metals. It's going to react with metallic sulphides. Basically, it's going to react with metallic sulphides. So one thing you have to remember is different when this reacts. Suppose if it is dilute, it gives a different product. When it is in concentrated, it gives a different product. Right? So now with this basic data, let us start off the different reactions. So before that, let me make one tabular column for you. It will be very useful when you prepare for your further competitive exams, right? So what is that tabular column? Keep noting along with me, right? Let me move my page on this side and show you the next part. Right, so when I have to take this complete page, let me take my scale and make you all also do. First important thing I told you, it's being a strong acid, it's going to combine with all these. Now this strong acid, one more, suppose if I take the strong acid, if I take it under three different conditions, what are they? Let me make one tabular column for you. It's easy for you to remember. This is the most important tabular column for nitric acid, right? So first column we are going to write it for, or we'll write the heading as concentration. Okay, let me put it caps for this. We'll write it as concentration. Done. After this, the next column would be which one are reacting, metal, non-metal, or metallic carbonates, or sulfates, or what it is. Let us write. Suppose if it reacts with metals, what are the product? If it reacts with non-metals, what are the product? If it reacts with carbonates, what are the products? If they react with metal carbonates or bicarbonates, metal bicarbonates, what are the product? Suppose if it reacts with metal sulfate, what are the product? Suppose if it reacts with non-metals, what are the products, right? And that's the different things. And finally the last would be the reaction part, which I'll be explaining, right? The last would be the reaction, what type of reaction it's going to show. So let us make one thing here with the scale. That's over. For the basic thing, I'll give you the general thing, and then we will go to the specific reactions of each. The first one, when I have to take the first one, let's see. So here concentration, so it can be three different conditions. We'll see. The first thing, remember, this is a very important chart for your examinations. Remember students, so I'm writing this as important. Let me take one more sketch, very important, right? Now Suppose if I take the same nitric acid, what am I going to do? I'm going to take very, very dilute nitric acid. So very dilute. What is dilute means? I'm going to take basically very dilute, that is 6% only, 6% of nitric acid. In next condition, I'm going to take again nitric acid, but here this is not very dilute, this is only dilute. How much? 20% I'm taking. Next would be third one, I'm going to take nitric acid which is concentrated. So this is concentrated. How much is the nitric acid here? 70%. So all three criteria done: very dilute, dilute and concentrated. Let me take the third one and show it to you. I've written it as concentrated nitric acid. Right, students? Right. So first of all, whenever I take the very dilute nitric acid, what products do we get? Suppose we have some concept called reactivity series, isn't it? Right. So based on that, suppose if I have magnesium and manganese reacting, remember the product formed is always right? So remember magnesium, manganese, and if I take iron, zinc, copper also, right? So basically magnesium, manganese, iron, zinc, copper, all these, what do they give? Metal plus nitrate. What does it give? It's going to give metal nitrate, the first one, plus it is going to give hydrogen gas. Right? Let us see the reactions very soon. Done, students? Right. Suppose if I draw this line, I'm again writing the same this one here also. Just see one example I'll take, so it's easy. Magnesium plus HNO3, which is dilute condition, very dilute. I get magnesium nitrate, NO3, valency of magnesium is 2 plus hydrogen gas is 1. Over, students. Done. This is one example. I'll later take all the different examples. See. Now, let me take the next one. Next, metal plus dilute nitric acid. So again, according to the reactivity series, just see metals like lead, metals like copper, metals like silver, metals like mercury, right? They are going to give the product as metal nitrate as one product. They are going to give plus NO as one more product, plus H2O as one more product. Remember that. Suppose if I have to take one example here, what am I going to take? Tb, plus HNO3. What do I get? I get three different products. What are they? Lead nitrate, the valency of lead is 2, plus NO, nitrous oxide, plus water is 1. Suppose if I have metals like, just see students, I am bifurcating it. Suppose if I have metals like, for example, if I take, let me fold the page like this. Yes. Suppose if I have metals other than lead, copper, silver, so the different varieties, not other than these. If I have to take, let me adjust the page for you all. Yes. Okay, let me fold it also for you all. I am folding the paper so that there is no disturbance for you all, students. Right, I am folding. Is it clear now? Yes. So suppose other than lead, copper, silver, if I have a combination of other metals like iron, zinc, suppose if I have Fe and zinc, right? What are the products from? Basically it is metal nitrate, Mn, plus N2O plus water. Done. Right. Let us write the reaction. Example, I am taking Fe plus HNO3 gives me Fe, NO3 taken twice, plus N2O plus water. I'll write it elaborately also. Next, suppose if I have a metal like tin, you will be getting a product like tin plus nitric acid. You will be getting SnNO3 taken twice, plus ammonium nitrate. Okay, little bit clumsy it is. I'll try to write the reaction later. Right, next one. Suppose if I take concentrated nitric acid, you need to remember this, students, very important, dilute and concentrated. Suppose if I am taking concentrated nitric acid, if I take metals like zinc, iron, lead, copper, silver, what are the products I get? I'm going to get metal nitrate, plus I'm going to get nitrogen dioxide, plus water. Right, students? Yes. So remember one thing. There are certain reactions like where nitric acid releases hydrogen gas also. Those reactions also I'll be showing it. Like reactions like manganese, reactions like copper, where I'll be showing further which gets converted to water. So that reaction also we'll be seeing very soon, right? So here, suppose if you have concentrated nitric acid with SN, right? So you'll be getting a product of NO2 gas, right? So now when it is SN, what do we see? When they're still in reaction with concentrated nitric acid, you have to remember that the products which we get are basically, nitrogen dioxide gas as well as H2SNO3, right? So as of now, I've just made this tabular column. But here, what you should remember is, whenever you're using dilute HNO3, that means very, very dilute HNO3, and when metals of this variety are reacting, right, like magnesium, manganese, iron, zinc, copper, you will with very dilute nitric acid, you will be getting hydrogen gas. Remember this. Suppose if you're taking dilute nitric acid, that is almost 20%. And if these metals are reacting, you will be getting NO plus water, right? So because this is an oxidizing agent, so you'll be getting nitrous oxide as well as water. Suppose if you're taking more reactive metals like iron and zinc, you'll be getting N2O plus water. Further, when you're taking concentrated nitric acid, you will be getting NO2 gas. Remember, the concentrated this means nitrogen dioxide gas as well as water. So this is the basic logic, means the basic reactions which we have to study or which we have to tabulate for nitric acid. Right. Now let us start off with the first reaction, that is, I said, dilute nitric acid, reactions of metals with dilute nitric acid. And let me turn the page and show you. Let us start off in all the reactions in detail, right? Whatever we have written, let us write those. Suppose if I take, as I told you, they are very dilute acid as well as dilute acid. Now, suppose if I am taking a condition, what is that? Reaction with, let me take one more pen of mine. Yes. Suppose if I am taking reaction of metals with what I am taking? Metals plus dilute HNO3, that is dilute. I am taking the first condition, very dilute, just taking it and this is very dilute condition, and I'm showing you the reactions. Right, students, hope the heading is clear. Right. So when I take very dilute reactions, so let us take different metals which I have told you. First, what do we write? Whenever we have very dilute, what is the reaction? Metal plus dilute nitric acid. What product do we get? We are going to get metal nitrate and hydrogen gas. This is what is the reaction which we are going to learn. Hydrogen gas is important. Let us take different examples now. First, I'm going to take zinc and I'm going to take HNO3. All these are dilute. I'm not writing specifically here. What do we get? Metal nitrate means zinc nitrate, and how much is valency? 2. And what else is there? Hydrogen gas is released. Done. Suppose if I take iron, here I'm going to take, this is cold and dilute. Here I'm going to take nitric acid, aqueous state. What do you get? Again, I get metal nitrate, FeNO3 taken twice plus hydrogen gas. Simple, isn't it? Now let us take one more. Now I'm going to take manganese plus nitric acid. What do I get? Again, metal nitrate, that is manganese nitrate taken twice plus hydrogen gas. Done. Now next thing, copper. Suppose if I take HNO3, again same story, copper nitrate, that is your metal nitrate, copper nitrate plus hydrogen gas. So this is quite common, isn't it? Right? So common compounds, that is metal nitrate plus hydrogen gas. Remember this as a first set. So whenever you are adding dilute, you will be 100% getting hydrogen gas as the one of the product. Done, students. This is over. Yeah. So now one more thing you have to remember. Here, zinc. Specifically, you have to remember one important thing. Just see. So whenever I have zinc with dilute, there are two things which you have to remember. So there's a difference. Metals like zinc. For me, zinc nitrate. Here what happens? You should remember this. That's specifically I'm writing. Zinc is 1. And as I told you in the first, magnesium is 1 more. Manganese also 1 more. Yes. So there are certain special cases. I'll mark that here. I'll be writing it down. Yes, students. So magnesium also will write. I've marked this. I'll explain about this very soon. So magnesium plus nitric acid. Very dilute, if I have to say, I get magnesium nitrate plus hydrogen gas. Isn't it done? Yes. Now here you have to remember one thing. What are they? According to the table which we have written, elements like zinc, elements like manganese. Sometimes, as I told you, as I've marked, they're going to show a specific reaction. What are they? That is zinc. Suppose you're taking HNO3 and you're adding here cold and dilute. 8 moles I'm taking, cold and dilute condition. I'm going to dilute condition of nitric acid I'm adding. First, as mentioned, you get zinc nitrate, that is done. Zinc nitrate, HNO3. Along with that, we'll be getting nitrous oxide plus water also. So if I have to balance 3 of this, 3 of this, 2 of this. This is one more condition and water. This is done, students. Metal plus very dilute acid. Suppose if I have to take metal plus concentrated acid. What is the product? We said metal plus concentrated acid. It's nothing but metal nitrate plus nitrogen dioxide and water. Here we have written different elements. Basically, nitric acid is a strong oxidizing agent, isn't it? So let me fold the plate. What is the basic thing of nitric acid? It is a strong oxidizing agent. Yes. So because of the strong oxidizing, what happens when any metal reacts with nitric acid? Whatever hydrogen is released, it does not mean hydrogen gas only is not released during concentrated nitric acid. Why? It oxidizes free hydrogen into water. Remember that condition. What is that condition? Just see. Second thing, reaction with concentrated nitric acid. So concentrated nitric acid, what is it? As I told you, it's a very strong oxidizing agent. Right? Strong oxidizing agent. So what does it do? Right? What does it do? Whenever you're reacting with concentrated, first thing, no hydrogen is released. Remember this, with concentrated. What it does here in these reactions, whatever free hydrogen is there, you will see the reactions very soon. Free hydrogen, what will happen to that? It will get oxidized. Means the free hydrogen is oxidized to which one? Oxidized to water. Remember this. Whenever you see concentrated reactions, free hydrogen is oxidized to water. Right, students? Yes, I am writing this. Free hydrogen is oxidized to water. Let us see the reactions and see. Means let us write some reactions and see. Suppose, as I told you, there are 2 different products which are formed. One is nitrogen dioxide is one, right? And we also have nitrous oxide also one. Correct? Right. Let's write. Suppose if I take an example, first example, I'm going to take Fe. I'm going to add nitric acid to this, concentrated. What am I going to get? As I told you, metal nitrate is first one, FeNO3 taken twice, plus water, because hydrogen whatever is released getting oxidized to water, isn't it? Done. That's the first thing. Suppose if I take the next metal, copper. Let me take one more example here. Copper. Copper I'm combining with again nitric acid concentrated. What do we get? We get copper nitrate. And what do I get? As I told you, you're going to get NO plus water. If I have to balance this, 3, I'll take this also 3, I'll make this as 8, I'll make this as 2, I'll make this as 4. Done, students? Let us see one more. Suppose if I have elements like zinc, let me take zinc in the reactivity series. Suppose you are reacting with nitric acid here, concentrated. Remember, again you will get metal nitrate, zinc nitrate, Zn taken twice, yeah, and then here you will be getting NO2 gas plus water. So if I have to balance this, here I will be taking 4, here I will be taking 2, and here I'll be taking 2. Done, students? So what should you remember? Here just see, zinc, you're getting the gas which I get is NO2 gas. Copper, you're getting iron, you're directly getting, means here from the gas you're getting water. You need to remember like that. Yes, students? Yes. Now let me start with one more. Basically we have done dilute, we have done concentrated. Now let's start with the next variety of reactions. Yes, students, that is reactions with metal we'll start off with reactions with metal carbonates or reactions with basic oxides. That will be better, right? So let me take my page and shift it above a bit. Now what are we going to learn? We are going to learn reactions with basic oxides. So let us write the heading. Second one is reactions of nitric acid, reactions with basic oxides. Basic oxides. Done? Yes. So when I take basic oxide, what are the basic oxides basically? So basic oxides are nothing but calcium oxide, zinc oxide, lead oxide, copper oxide, isn't it? Suppose if I have to take or show the reactions of basic oxides with nitric acid, what is a thing you have to remember? As I told you, with dilute, I'll be getting hydrogen gas. With concentrated, I'll be getting water. With basic oxides, remember, basic oxide, as I mentioned on the top, basic oxide plus nitric acid. Now here what are we going to take? Aqueous form of this dilute. What do we get? We get nitrate salt. Nitrate salt plus water. Done, students? Let's start off with the examples one after the other and just complete the revision one. Suppose if I take the basic oxide, that is calcium oxide, solid. I am adding nitric acid to this aqueous. So let me take calcium oxide, zinc oxide, lead oxide, copper oxide. Everywhere it is the same aqueous. What do I get? In case of calcium oxide, I'll be getting, as I told you, nitrate salt. It is nothing but calcium nitrate plus water L. This is aqueous form. Here in the second case, what do I get? I get zinc nitrate plus water. Same, aqueous and liquid. Here in this case, what do I get? I get lead nitrate plus water. Same, aqueous and liquid. In copper case, what do I get? Copper nitrate plus water. This is done, students. So remember, basic oxides, that is when they react with HNO3, that is aqueous, this is the product which is formed. Hope this is clear, students. Now let's come back and see one more. Right, let's come back and start off with the next one. So after basic oxides, what shall we do? Shall we do the reaction with hydroxides? Yes. Let's turn the page, the next one, and come back to this page. Let me fold the page like this and write it, students, so that it's clear for you all to note. Okay. Now let us start off. We have seen dilute reactions. We have seen concentrated reactions. Now here we'll be seeing reactions of nitric acid, right? Reactions of HNO3 plus hydroxides. So what do you get? Whenever you're reacting nitric acid with hydroxide, let it be, what are the hydroxides? Basically hydroxides can be like sodium hydroxide, calcium hydroxide, or magnesium hydroxide. Let me write magnesium hydroxide. Then it can be copper hydroxide, right? It can be lead hydroxide, like that. So let me write copper hydroxide, like that. Examples. I have taken these examples. Suppose if I take these examples and I am reacting, so let me move the page down. What did we write? We have written sodium hydroxide, magnesium hydroxide, copper hydroxide. If I write all these, what are the products from? Reactions of nitric acid plus hydroxide, you get, always remember, you get nitrate salt plus water. Right, students? So nitrate salt, earlier also we have seen that same thing. So whenever hydroxides are reacting with nitric acid, you'll be getting nitrate salts and water. how to write. Let us see that examples, right? Hope the page is clear. So what is the first example we have? What is the first hydroxide we have taken? We have taken the first hydroxide as sodium hydroxide. Sodium hydroxide plus nitric acid. So it is aqueous. What did I say? Nitrate salt. That is NaNO3. Simple. NaNO3 aqueous plus water. What is left out? H2O. H2O is left out plus water. What is it from? Liquid form. Now same thing. If I take magnesium hydroxide, what do I get? Magnesium hydroxide I am getting. Same I am adding. Instead of NaNO3 I will be getting magnesium nitrate plus same aqueous and liquid. Suppose if I am taking copper hydroxide, same thing I will be getting. Here I will be getting copper nitrate plus water. Done, students, right? So this is how the reactions. This is how we're going to learn different reactions of nitric acid. Now after basic oxides, after hydroxides, shall we start the reactions with metallic sulfates, students? Yes, we will start off with the metallic sulfates, so that we have carbonates, we have bicarbonates also. Let's start. Now metallic sulfates, then we'll go with carbonates and bicarbonates. Let me take my scale and draw. Right. Suppose if I have to take reactions of this one with carbonates and bicarbonates. Let us divide the page into 2 equal halves so that it is not confusing you. So here I am going to take reaction with carbonates. Then here I am going to take reaction with bicarbonates. Right, students? Now, carbonates and bicarbonates. Remember, whenever carbonates are reacting, okay, so like calcium carbonate, sodium carbonate, lead carbonate, copper carbonate, right? So whenever carbonates are reacting with which one? HNO3, that is aqueous, diluted form. Whenever bicarbonates are reacting, let us take this, and you're going to take HNO3, that is aqueous. What do you get for carbonates and bicarbonates? So for carbonates, when you take, you will be getting nitrate, salt, water plus carbon dioxide. Now for bicarbonates also, it is the same product. Remember that. That's the reason I have written one beside the other, so that you'll have an understanding. Okay, students? Yes. So what is the listen? Let us take one example. Let it be sodium carbonate. Let it be lead carbonate. Let it be copper carbonate. Right here, let it be sodium bicarbonate. Let it be calcium bicarbonate. Let it be this is calcium bicarbonate 2. Okay, or let it be so sodium calcium. Okay, done. So here, if I have to add HNO3, same here also, same here also. Here also same HNO3, here also same HNO3. What product do I get? As I told you, I'll be showing one. This is NaNO3, nitrate salt. Along with that, water. Along with that, carbon dioxide. Here same, students. Lead nitrate, water, carbon dioxide. Copper nitrate, water, carbon dioxide. Same with sodium bicarbonate also. There you will be getting sodium carbonate. Sodium bicarbonate dissociates into sodium nitrate. Let us write this one. It become sodium nitrate plus carbon dioxide plus water. Here also calcium nitrate, carbon dioxide plus water. Right? Done, students? Yes. So this is how you have to remember. Whenever you are reacting with carbonate plus nitric acid, you get nitrate salt plus water. Here also same thing. That is how you have to understand. Now after carbonates, after bicarbonates, after this dilute nitric acid, concentrated nitric acid, now let us come back and write the reactions involving metallic sulfates. Let me turn the page and fold and show you. I'm taking this page. Yes, I'm folding this page. Now let's see what happens when your nitric acid reacts with metallic sulfate. So I'm writing it here. Reaction with metallic sulfates. Okay, what is that? Metallic sulfates. Right. So metallic sulfates, remember, whenever metallic sulfates react with nitric acid, what is the state of this? This is again aqueous. Means concentrated, you have to remember, it is always water, and the hydrogen is oxidized to water. what do you get? You'll be getting metal nitrates plus sulfur dioxide plus water. Remember this. Suppose if I take, let us take certain examples. Right? If you're taking bicarbonates, you will get carbon dioxide plus water. Metal nitrate is same. Right. So as I've told you, metal sulfate, you will be getting metal nitrate plus sulfur dioxide plus water. Let us see one example. I am taking one metallic sulfate, that is sodium sulfite. I am going to take calcium sulfite, solid. Right? This is also solid. So I am going to take nitric acid. Here also I am going to take nitric acid. Here what are we going to take? Aqueous, that is dilute. What do you get? Same. NaNO3, that is metal nitrate, sulfur dioxide gas is 1, and water. Remember, here also what do we get? Calcium nitrate, sulfur dioxide gas plus water. Calcium taken twice because valence of calcium is 2 plus sulfur dioxide plus water. Done, students? So what reactions did we see? We have seen reactions with dilute nitric acid. We have seen reactions with concentrated nitric acid of metals. Then we have seen reactions of carbonates with nitric acid. We have seen reactions of bicarbonates with nitric acid. We have seen reactions of metallic sulfates with carbon dioxide. Right? We have seen reactions with basic oxides. Then we have seen reactions with hydroxides. Now, let us see the last reaction, that is reaction with non-metals. So basically we have written non-metals, and one more category is also there with oxides, that also sulfur dioxide, H2S, we'll see that. So in the next reaction, the last but not the least, reactions with non-metals. Remember this is also very, very simple, students. So basically whenever, what are the non-metals? Carbon, sulfur, phosphorus, all these are non-metals, isn't it? Suppose when you are reacting with that, I'll take the basic example, carbon. So carbon is nothing but graphite, isn't it? Yes. So when I take carbon, when I'm reacting with nitric acid, what do I get? The first thing which I get is, just see, there are two things. I'll be taking the same example, the balancing would be different, the product also would be different. Right. So here HNO3, just see. Suppose here if I'm taking the first one, you get two products. One is carbon dioxide. In both the cases, carbon dioxide is compulsory. But in one case, you will be getting nitrogen dioxide. In the second case, you will be getting NO. In both the cases, you will be getting water. So what are common here? Basically, in both the cases, carbon dioxide is common. When you react non-metal, water is common. What is different? This is different. So why is this difference? Because while balancing, there will be a difference of nitrogen. Just see. First one, let me balance. This is 4. This is 4. This is 2. Here this is again 3. Let me take this. This is 4. And this is 3. This will become 4. This will become 2. 2 2s are 4. 4. Okay, balanced. So based on the balancing, there is difference of or release of different types of gases. So remember, with the non-metals, that is the case. Next thing, last but not the least, what will happen when your nitric acid means concentrated? Now till now we were doing dilute. Now let's see what will happen when concentrated nitric acid reacts with the following. Right, let's list out those also. The last column means, with this I've covered all the reactions of nitric acid. Now let's see reactions. What are they? Suppose if I have a concentrated nitric acid with me, and concentrated nitric acid is reacting with sulfur dioxide gas. Concentrated nitric acid is reacting with potassium iodide. Concentrated nitric acid is reacting with HBr. If it is reacting with HI, if it is reacting with Fe+2, if it is reacting with FeS. Let us see this, because till now we have seen dilute, all reactions are dilute. Now let's see the reactions of concentrated. So sulfur dioxide, it's going to release nitrogen dioxide gas. Everywhere, whatever reactions are there, everywhere you will be getting a release of nitrogen dioxide gas. First remember that. That's the reason I have given this as a separate set of reactions. Everywhere nitrogen dioxide. So let us mark. So whenever concentrated nitric acid reacts with these, you will be getting nitrogen dioxide gas. Understood, students? Now let us write the product. The last topic of this. So HNO3 plus sulfur dioxide gives sulfuric acid, right? So HNO3 plus Ki. Just see, as I told you, nitrogen dioxide gas is released out, and what is left? This being an oxidizing agent, you'll be getting I2. For Br, you'll be getting Br2. Yes, students? Yes. So for one more, Hi, here also you'll be getting I2. Yeah. Suppose if I have Fe plus 2, no, this should be Fe plus 2. This gets converted, loss of electrons, Fe plus 3 plus NO2. When you have FeS, just like this, S2, SO2, you got H2SO4, here you will be getting FeSO4. Done, students? So with this, I have covered all varieties of reactions of nitric acid. What did we learn? We have learned, let us list out. We have learned the reactions. Shall we summarize the whole reaction, students? Yes. We have seen reactions of, let's summary. I'm writing the summary of all the reactions so that it is easy for you. I have done reactions of HNO3. I have done for both dilute and I have done for HNO3 concentrated. Okay, what did we see? We have learned the reactions with metals. What with metals I have seen? I have seen reactions with both the cases, non-metals. Then I have seen reactions with metallic sulphides. Then I have seen reactions with carbonates. Then I have seen reactions with bicarbonates. Then I have seen reactions with non-metals, isn't it? Then I have seen reactions with elements like sulfur dioxide. Let us write that. I have also shown you reactions with sulfur dioxide, H2S, Ki, Hi, HBr, FeS, Fe plus 2. This is how. Yes. So if this is the case, you know, like different reactions. Here I've listed out different ranges, hence I've also taught you what happens when non-metals react, what happens when nitric acid reacts with dilute like that. So hydroxide also I think you've done. I've missed out that. Let me write reactions with hydroxide also. So many reactions I did. So please practice it. Very important reaction, students. As the acidic nature of nitric acid, if I have to conclude, basically, why do we call nitric acid as a strong acid? Because when it is dissolved, or when it dissolves in water, basically, so nitric acid, what happens when nitric acid, it reacts, or when it combines with water, what product you get? Combines with water, forming hydronium ion. Because of this release, we call it as, because of the formation of hydronium ion concentration, we call it as a strong acid, NO3 and aqueous, aquafortis, right? That is why we call it as aquafortis, the strong acid in chemistry. Thank you for watching, students. Stay connected, practice all the reactions. I'll meet you again very soon with the next video.